Okay. So we're going to work with rational functions in section 3.6, and I want to look at one in particular just to kind of get started with and acquaint you with some of the things that can happen when you're looking at the graph of a rational function. It's y equals 2x plus 6 over negative 6x plus 3. Now, looking at this, you may imagine that this function can have problems at a particular value of x. Let's try and figure out what that value of x is. I guess my big concern is that the denominator not be 0. So, okay, where could the denominator be 0? Let's find out. Negative 6x plus 3 equals 0. Well, it's negative 6x equals negative 3. And hopefully you would rationalize this and put it in lowest terms. So you get 1/2. So at x equals 1/2, this function could have problems. So let's investigate the function near 1/2. Okay. So I want to look at what happens as x approaches 1/2. And now, when I do this, I can approach 1/2 in two ways. I can approach 1/2 from the positive side or the negative side. And I choose that because it's the right and left-hand sides of this. So we're going to choose to approach x equal 1/2 from the positive side. And for that, let's turn it over to our little Desmos demo right here. So I've got this little t-table here. I've plugged in my function. And I want to see what happens when I plug in values of x that are close to 0.5, but a little bit above 0.5. And you can see the first 2 points plotted right here. Okay. But what if I get closer to 0.5? Let's do the next one. So if you put your cursor next to the 0.58, 0.57, 0.56. And you should be able to see at the same time that I'm also getting new points plotted on my graph. So watch in the lower right. New point, new point, new point. Where are those new points going? Down, 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 towards what? Towards negative infinity. And I can go a couple more. Now, we lose track of it on the graph because we can't see like forever far south, but you can see a couple more on the graph until you get to 0.5 itself. And then, of course, it's undefined. So what does that leave us to say or conclude? What that says is that as x approaches 1/2 from the right, y approaches negative infinity. Okay. What happens if we approach 1/2 from the other direction? What happens if we approach 1/2 from the negative side? Let's see what happens to the value of y this time. So for that, let me go to a different table. And we can watch things over here. Put your cursor here, and then just press enter. And you can see the dots coming into play on the right-hand side of this. But in general, what's happening? As I get closer to 0.5, what's happening to my y values? Yeah, they're getting bigger and bigger, and they approach infinity. So, okay. So that's a couple of behaviors of this graph. Now there's some more behaviors as well. And I want to look at the behavior in one more way. And that is, what if the values of x get really, really big? That is, instead of looking at x approaching 0.5, what if I let x equal 200, then 400, then 600, and so on? I can just keep on typing enter. Do these values of x explode or do the values of y explode, or are they settling down to something? Kind of settling down, right? In fact, I'm getting 0.33333333, Yeah, it's tough to get that fourth one to turn into a 3. Come on. All right, it's not going to get there for a while. Let me just cheat and we'll bump this up really big. There we go. So eventually we're going to get a lot of 3s here, right? All right, I took a little shortcut. But what is that number getting close to? What does it look like as a fraction? Can anyone recognize negative 0.33333 repeating? Negative 1/3, right? So that's what happens when we go out towards positive infinity. And if you go out towards negative infinity, a similar thing happens. Again, the graph settles down to this same value of negative 1/3. So what can we say about that then? Oops, wrong one. Here we go. So as x approaches infinity, y approaches negative 1/3. And as x approaches negative infinity, y still approaches negative 1/3. And there's no rhyme or reason for why I used 2 arrows here. All right, it means the same thing as x approaches. So the little arrow means approaches. So what are we seeing here? Well, we're seeing this kind of behavior, that in the one direction, as you approach x equal 1/2 from the right, your graph is approaching negative infinity. And from the other direction, as x approaches 1/2 from the left, you're approaching positive infinity. But in between, if you all want to borrow some rulers, there's plenty up front. In between, there's a feature of the graph that's not really drawn here, but is kind of understood. And that is you have a vertical asymptote. A vertical asymptote is going to be like this, right here. So it's not really a feature of the graph that you plot with points, but the graph comes close to this from either direction. Now there's also another feature of the graph that we kind of saw in looking at this, and that is it settled down horizontally as well. And where did it settle down to? It settled down to about negative 1/3. So that's your horizontal asymptote. So we have 2 asymptotes for this graph. We have y equals negative 1/3 and x equals positive 1/2. Those are the 2 asymptotes for this graph. Our goal in this section is to find these horizontal and vertical asymptotes. That's the goal. And with the help of our handout, we should be able to find those. So this is your vertical asymptote. This is your horizontal asymptote. So finding the vertical asymptote is going to be easy. What do we have to look to find our vertical asymptote? What did I do for this particular problem? Yeah, you look where the denominator equals 0. So on the handout, back side of the handout that I just gave you, we're going to assume that we're working with a rational function that looks like this. It's some p of x divided by q of x. These are rational polynomials, where p and q are each polynomials with no common factors. If that's true, then we can find, let's see, the vertical asymptotes by setting the denominator equals 0 and solving. Okay. Now we're not going to worry about solutions that contain I, because we're not going to graph, imaginary asymptotes. But wherever there's a real solution, that's a place where you're going to get an asymptote. Now, how about your horizontal asymptotes? Horizontal asymptotes present a little bit more of a challenge. There's 3 different types of horizontal asymptotes. The first one is the case that we just dealt with, where the degree of the numerator equals the degree of the denominator. So if that's the case, then y equals a over b will be the equation of your horizontal asymptote, where y, it's going to be a and b, are the leading coefficients of the numerator and denominator, respectively. So how's that work for this one? Well, good question. We got y equals 2x plus 6 over negative 6x plus 3. The leading coefficient in the numerator is the 2. What's the leading coefficient in the denominator? Negative 6. So overall, y equals 2 over negative 6 reduces to negative 1/3. That's your horizontal asymptote. And that matches what we saw when we looked at the graph. Horizontal asymptote. Be careful how you abbreviate asymptote. All right. We also had a vertical asymptote. And that was at x equal 1/2. That's where the denominator was equal to 0. Hey. All right, so I think we've kind of got a pretty good understanding of this graph. Let's see what else we can kind of understand based on these things. And for that, we'll look at problem number 54 next. But are we okay here? Okay with these two? Yeah. Oh, the other side? Okay. There we go. So you had your vertical asymptote and your horizontal asymptote.
How did you get the vertical asymptote without looking at this graph?
Well, we can calculate the vertical asymptote. That was the very first thing we did. Was we set the denominator equal to 0. So where the denominator was equal to 0 was x equal 1/2, and that's where you're going to have your vertical asymptote. In fact, I appreciate the question because it reminds me of a little demo that I can do for you. Let's see here. Let's see. We got it right here. Yeah. So let's look at a very simple graph. Y equals 1 over x. Where am I going to have a vertical asymptote for this graph? 0, right? Right at the y-axis. So you can see that. Now, if instead of 1 over x, I had 1 over x squared, I'm still going to have an asymptote at 0, right? The difference is this. Here, to the left of the y-axis, the graph goes towards negative infinity, and here it goes towards positive infinity. But with this graph, both go to positive infinity. Can you understand why? Why would that change? Yeah, because when you square this number, you're going to get a positive number. So you divide a positive by a positive, you get a positive quotient. So even though these numbers are getting close to 0, and divided by a number close to 0, it's still going to go to positive infinity. Whereas with this one, with the left branch, once you cross over the line of x equals 0, then this quotient is negative. So instead of going to positive infinity, you're going to go towards negative infinity. Now overall, when you have the graph of 1 over x, 1 over x plus a constant, you expect a vertical asymptote at that constant. So if I change things, it's just going to shift. Left and right. And here's where you go, ooh, ah. All right, good, thank you. Appreciate that. But it's kind of cool that you can actually see that changing the value in the denominator just changes where the asymptote is. You have the same shaped graph no matter what. All right. Thanks again for that question, Margaret. Let's take a look at problem number 54. By the way, in association with that last one that we did, we had a graph of 1 over x, y equals 1 over x. What's the degree of this term in the denominator? That's a first degree polynomial. How about the numerator? It's a 0. It's kind of weird. It's a 0 degree polynomial, all right? But that actually satisfies this case. The degree of the numerator is less than the degree of the denominator. And that actually tells us something else about the graph. So if the degree of the numerator is less than the degree of the denominator, then y equals 0, that is, the x-axis, will eventually be its horizontal asymptote. Let's look back at those graphs for just a second and see that that's the case. If you take a look here, let me shut these off. There you go. Eventually, this graph gets really close to the line y equals 0. So that's an example of case A from our little sheets here. All right, as promised, problem number 54. R of x is 2x squared plus 10x minus 12 over x squared plus x minus 6. Okay. Let's see what things we can figure out about this. Let's go for some low-hanging fruit first. And that low-hanging fruit would be this. Let's find the Y-intercept. How do you find the Y-intercept of a graph? Yeah, set x equals 0. Okay, so if I set x equals 0, that should be pretty easy. This is 0, this is 0, this is 0, this is 0. What's left in my numerator and denominator? Negative 12 over negative 6, which is 2. So my graph should have a y-intercept of 2. Nice. Now, one of the important things that I'm going to ask you to find about your graph is going to be the vertical asymptotes. Vertical asymptotes. What do I have to set equal to 0 to find those? The denominator, x squared plus x minus 6 equals 0. Do I have to pull out the quadratic function with that one? I hope not. I really think it would slow you down if you did that. Eric, how's this going to factor, please? Let's see, I need two numbers that multiply to negative 6 and add to 1. All right. Kim up front's got your back. So plus 3 and minus 2. Thank you. So that gives me roots at what points? Negative 3 and positive 2. Cool. So I expect vertical asymptotes here. And while I'm on track to do the asymptotes, let's also figure out the horizontal asymptote. And for that, we might want to look back at our handout. Looking at our handout, what do we see? Which case is it, A, B, or C? Well, let's take a look here. How do the degrees of our numerator and denominator compare? Scott? They're the same, right? So which case is that? B. If they're the same, then our horizontal asymptote is just going to be the ratio of the leading coefficients. In other words, 2 over 1 or 2. So wow, this frames our graph a lot. All right, we see a lot about what's happening with the behavior of this function. Let's see. Let's graph this. Let's graph it on our graphing calculator. Now I'm going to make a mistake in entering this thing on purpose. So let's see, it's going to be 2x squared plus 10x minus 12 divided by x squared plus x minus 6. And knowing what I do about the asymptotes, I've got asymptotes at -3 and 2. Let me set up a window that's wide enough to see those asymptotes. -5 to 5 should work. And I don't know exactly what to see on the x-axis, so let me go from -6 to 6. Just at a guess. You can always readjust these things later. And wow, I'm not really seeing much of what I expected at all, right? That's not a vertical asymptote, and it's at the wrong spot. So if you're not seeing exactly what you expected, what do you think's wrong? Either something's wrong with your calculation or something's wrong with the way you put this into your calculator. Can you see what I did wrong with the way I put that into my calculator? I need parentheses. So the fix for there is you hit the second key, then the delete key, because above that is insert. Now I can insert a parenthesis here. Let me go over here and insert some more parentheses. And some more parentheses. And down here at the end. That should be a better looking graph. Let's take a look. There we go. Nice. Kind of snakes its way through there. Notice the Y-intercept. If you hit the trace key, there you go. 0, 2. Right there where we expected it. If we wanted to zoom out a little bit, we can do that. We might get a better look at the horizontal asymptote. The horizontal asymptote was y equals 2. So let's just add that to our graph real quick. But you might need to see this graph a little bit wider. So let me go -10 to 10. See if that helps out at all. Now your graph can cross the horizontal asymptote. That's not a big sin. But at least it looks like it's getting close to 2 from either direction. And so on a test, I'd want to see the horizontal asymptote. The vertical asymptotes you're going to have to draw for yourself. You can't just make your calculator do those too easily. And let's see. There's a couple of more things that we could find here. Before I find the X-intercepts, are you okay with what we did to find the vertical asymptote and the horizontal asymptote? Kennedy? There are some tricks that you can do to get the vertical asymptote, but it might also be an artifact of the way the calculator drew things, because the way your calculator plots things is that it divides up your screen into a bunch of points, and then it plots points and then it connects them. So sometimes with the correct settings, you'll have a point way down here and a point way up here, and your calculator's trying to draw, and it connects it with a straight line. It looks like a vertical line. So it might be, depending, especially if you have like an older 83, then that's probably what's happening, is it's trying to draw that vertical line because it thinks that that's what the graph is. The 84s tend not to do that as much. but that's what's going on. It's okay. It's just reminding you of what you should expect anyways. There's a vertical line there. So thanks for the question. I found my X-intercept. How do you find the Y-intercept? Or I found my Y-intercept. How do you find the X-intercepts? Set y equals 0, which equivalently means set the numerator equals 0. So for us, that's going to mean 2x squared plus 10x minus 12 equals 0. I'll factor out the 2, x squared plus 5x minus 6 equals 0. That factors a little bit more. X plus 6, x minus 1. Is that right? Yeah, that's right. Why am I bothered by that? X equal negative 6, x equal 1. Oh, yeah, okay, good. So, all right, it was bothering me for a second. So you expect roots at negative 6 and negative 1. And with my zoomed out graph here, I can actually check that that's true. If I hit the trace key, I can choose my own values. If I choose negative 6, oh, negative 6 and 0. Crosses the x-axis, great. If I trace a 1, negative 1 and 0. Again, crosses the x-axis. So the roots are exactly where I expected them. So we got negative 6 and 1 going along with x equals 0. Other way around. My bad. Negative 6 and 1 goes along with y equals 0. There. Never happened. Okay. Are you comfortable with finding horizontal asymptotes and vertical asymptotes? Because that's as far as we can get here today. We still have to find oblique asymptotes. So I do have a little bit more work to do in this section. Not to figure out exactly how I want to catch up. But are we okay with problem 54? Anything else there? Yeah. Yes. Yeah. Let me give you a few homework problems to go with that. So for homework, let's just look at problems 31 through 43. So just a good handful of problems, and nothing more than what I was looking for here. Just find the vertical asymptotes and horizontal asymptotes. Look, you'll have your graphing calculators with you. You can check these things. So you should be able to get a good graph out of this. Good luck and see ya.